Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. First of all, I want to say thank you to Borobudur International Symposium because held this event on this year so I can present about my study. The topic is about tidal influence analysis due to development of retaining wall for flood control in downstream Bekasi River. First of all, I want to introduce myself. My name is Variando Yubeka Putra as the presenter and the author from Magister Studi Program of Water Resource Management, Faculty of Civil and Environmental Engineering, Bandung Institute of Technology. The second author is Faradinda Prabandini, same as me from Magister Studi Program of Water Resource Management, Faculty of Civil and Environmental Engineering, Bandung Institute of Technology. And the third author is Ana Nurgana Haidar. It's from Water Resource Engineering Research Group, Faculty of Civil and Environmental Engineering, Bandung Institute of Technology. Let's begin the presentation. Background to the problems. So why I choose this topic is I have the three big issues. The first issue is about the flood disaster at the beginning of 2023 was severe, causing significant damage to vital infrastructure and affecting at least 135,203 individuals. The second issue is about the population density in the city and Regency of Bekasi forced residents to live along the banks of the Bekasi rivers, and this is further exacerbated by the lack of regulation of illegal constructions in the river area. And the third issue is about the people in Bekasi are still disposing of into the river and leading to piles of garbage. Due to the generally flat topography, the situation significantly increased the potential for flood. And this is the documentation of flood at Bekasi River 2023. As you can see, the blue point is the flood points. Like this is the pictures of the flood that happens in Bekasi on the beginning of 2023. This is the explanation about the study location. So my river is in the Bekasi catchment area, and this is the yellow round is the river. So it's a big catchment area, but the river is around 110 kilometers. The method. So the first, I do the literature study, and then I do the field survey. I'm going to the Bekasi River to see the real conditions of the river and the flood, the color, and the other problems. After that, I do the data collecting, primary data and secondary data. The primary data is about the measurement and the river geometry. So I do the measurement by me with the team of the lab. And then the secondary data is topography data that debit data, rainfall data that I got from the institution that's engaged in that in Bekasi River. And then the secondary data is tidal data and then elevation of high water level, medium water level, and the lower water level. The third one is the hydrology analysis. And then after I do the hydrology analysis, I do the hydraulic analysis to know the debit. Then I can do the software running. The software I use here is with HECRAS one dimension. So from the hydrology analysis, I got the rainfall, and then from the hydraulics analysis, I got the debit, so I can put it into the software using the HECRAS, and I do the calculate, and then the results and conclusion, and after that, I got finish the study. Next, the analysis and the result. So this is the polygon design of Bekasi catchment area. So there is 3 stations, rainfall station, Cibongas, Cikeas, and Bandung Bekasi. which the total area is 407.58 kilometer. And then you can see too the rainfall level of the Bekasi catchment area. The average is around 100.99. Next, the hydrology results. So after I calculate the polygon design, I do the Smirnov-Kolmogorov test and chi-square test to see the validations of my data. From the frequency analysis conducted using the Smirnov-Kolmogorov and chi-square test, the smallest error figure was identified, namely log/3, and then the calculation for the planned rainfall was carried. So I used the log/3 because it's the more error is the more or less. This is the tidal analysis. I use least square method, and after the calculations program, I got the higher water level is 2.05. The medium level is 1.35, and then the low water level is 0.65. The tidal range is 1.4. So if I calculate the between the high water and the low water to the medium water level, the range is 1.4. And accordance with the guidelines stating that the tidal range, the Java Sea is still good. No, the scenario modeling, I use 6 scenario. Scenario 1 to 3 is using the debit of average 2022, and then the scenario 4 to 6 is using the key flood discharge that return period 10 years. So this is the result of scenario 1 to 3 with high-class software. There you can see that scenario 1 is the high water level. The scenario 2 is the medium sea level. Scenario 3 is the low water level. So this is the tidal range. The red line is the fastest tidal that affect that into the Bekasi River. So you can see too from the Google Earth I take. So this is the CBL River and this is the Bekasi River. So there is a confluence, and the tidal effect is 400 meters from the confluence. Now this is the result of scenario 4 and 6, 4 to 6 with high-class software 2. So with the flood discharge, because the debit is very high, so there is no affection of the tidal. You can see that the flood was very high from the top of the result. So the conclusion of the study that I do is when the flood discharge with recent period 10 years occurs, there is no influence of tidal fluctuation in the Bekasi River. But when the annual average discharge occurs, what I use is the average debit. So the tidal fluctuation enter the Bekasi River. The tidal fluctuation enter the Bekasi River up to a distance of around 400 meters, that it is located near the confluence of the rivers. Thank you. I think that's all about my presentation. Thank you and see you again.